Hi, this is Mr. Zapone here, and today we're going to look at total and net ionic equations. This is going to be a little bit dense. This stuff gets a little tricky because it really summarizes everything we've done thus far. You need to understand ions, polyatomic ions, how they're named, their charges, how they come together. We need to understand balancing equations and writing word problems, or writing chemistry equations, formulas from reading word problems. And it's going to require us to also understand dissociation and things of that nature, aqueous solution. So this really is going to summarize everything we've learned thus far. So hopefully we've been following along and can figure this out. So we have aqueous solutions of sodium hydroxide and copper 2 chloride. They're combining to form an aqueous solution of sodium chloride and solid blue copper hydroxide. So we're going to write a total and net ionic equation for this. And there's some steps we have to take first. First, we need to write a skeleton equation for this. We need to figure out what our basic formula or equation is going to be. Then we're going to have to balance the equation. Conservation of mass. We need the same number of atoms on each side. We're going to identify the spectator ions. Then we're going to write the total ionic equation, figure out what the spectator ions are, cross them off, and end up with a net ionic equation. So let's just go through and do this and see how it's done. So first off, let's talk about sodium hydroxide. Sodium's Na, Na plus. Hydroxide is going to be over here, OH minus 1. So because this is a plus 1, this is a minus 1, they combine in a 1-to-1 ratio. So I know this is NaOH. And of course, we're going to put a little AQ after it. That means we put it in water. But I just want you to understand that's NaOH. Copper 2 chloride, well, copper 2 means it's copper with a +2 charge. And what is the charge on chloride? Well, chloride's a -1. So you're actually going to need 2 chloride ions, anions, to balance. That's going to be CuCl2. Because copper has a +2 charge, chloride has a -1 charge. You need 2 of these so the charge balances. 2 -1s would balance perfectly with the +2. And they're going to form an aqueous solution of sodium chloride. Sodium's a +1, chloride's a -1. We know that. Sodium chloride is just NaCl. And now we have copper hydroxide. Well, copper is a +2. Hydroxide is a -1. So copper hydroxide's got to be CuOH with a 2. We need 2 hydroxides so the charge balances with the copper. Remember, the charge of this whole compound has to equal 0. This is a +2, and each of these is a -1. If we have 2 of them, that becomes a -2. +2 minus 2 cancels to 0. So that's just a little bit of ions, how they combine, charges equaling 0. And let's go see this. So we have, this is basically what we're doing. We are taking an aqueous solution of sodium hydroxide, NaOH, sodium hydroxide. It's aqueous, which means it's dissociated, it's separated, it's in water. So this ionic compound has been pulled apart. And we are taking a solution of copper chloride, CuCl2 aqueous, NaOH aqueous, and we're mixing them together. We're pouring both of them into one container. That's what we're saying. An aqueous solution of sodium hydroxide and copper chloride combine. And what are they forming? Well, they're forming sodium hydroxide, or blah, blah. They're forming sodium chloride and copper hydroxide. So what happens is the copper and the hydroxide are going to join together to form solid copper hydroxide. So we had NaCl, copper, and OH all in the container. And as it turned out, the copper and the hydroxide, well, they joined together. Turns out that this copper and this hydroxide, well, they joined together to form a solid. And these particles, they didn't do anything. They just stayed in solution, aqueous ions in the solution. So these were our spectator ions. And we're not there yet, but this is a solid precipitate. So we formed aqueous NaCl. They didn't do anything. They just stayed aqueous in the solution. And solid copper hydroxide. So this is our skeleton equation. It's not balanced yet, but this was the first step of what we had to do. NaOH aqueous plus CuCl2 aqueous yields table salt aqueous plus copper hydroxide, solid as a precipitate. Moving on from there, we know that we have to balance this equation. And the first thing we have to do is count the atoms. The same number of atoms on the left side of the arrow sign got to be equal to the number on the right side and of each type. So if you have one sodium over here, you got to have one over here. If you have three oxygens here, there's got to be three over here. Conservation of mass. Atoms are not going to just disappear. So if we were to count these atoms up, there's one Na, one sodium, one oxygen, one hydrogen, one copper, and two chloride. And do the same thing over here. We get one Na. There's actually going to be two oxygen because this 2 right here applies to everything in the parentheses. There's going to be 2 hydrogen for the same reason. This 2 applies to everything in the parentheses. We have 1 copper because this 2 does not apply to this. It only applies to what's right before it. And there's 1 chlorine over here. So right off the bat, we see that Na is balanced. And moving to the right, well, oxygen's not balanced. This side has an extra oxygen. So how could I fix that? How could I make this side have an extra oxygen? Well, I'm just going to put a 2 in front of here, and that will double everything in this formula. And if I do that, I now have to count atoms again. A little tedious, but we got to do it. So now there's 2 Na. There's now 2 oxygen, 2 hydrogen, and we didn't touch copper or chloride, so there's still 1 and 2 of them. And let's look over here. Well, unfortunately, we balanced our oxygen. There's 2 of them, but we unbalanced the sodium. So now this side over here has more sodium than this side. How could we fix that? Well, let's put a 2 here and see what happens. And when we put a 2 there, now we have 2 sodium on this side, 2 sodium on the other side. And there's still 2 oxygen, hydrogen. Well, we now have 2 hydrogen. This 2 applies to everything. When you have a large coefficient at the front, it applies to every single thing in the formula. There's still 1 copper, and there are 2 chlorine. So this equation actually is now balanced. So this is the balanced molecular formula. That's what we needed. So step 2 is out of the way. And now we're going to identify some spectator ions. Spectator ions do not take part in the reaction. So this was our balanced equation right here. We had 2 NaOH, right? And I separated them just to show that they're dissociated. They're aqueous. They're in solution. They're not together. They're not stuck together. The water separated them. 2 NaOH, 2 Nas, 2 OHs, are combining with copper chloride, and they're turning into NaCl aqueous and solid copper hydroxide. So when you put all of this stuff into water in a solution together, what happens is the sodiums, they don't do anything. The chlorine, or the chloride anions, they don't do anything. These are the spectator ions, the sodium and the chloride. The copper and the hydroxide all comes together. We end up with copper hydroxide solid. So that's our balanced chemical formula. We've identified our spectator ions, and we have a good visual picture of what's going on in the problem. So we did one. Now we have to write total and net ionic equations. And in doing that, there are some rules here, and we're going to see these rules in the next slide. We're going to dissociate the aqueous ionic compounds, indicating the correct formula, number, and charge of each. We have to bring down all compounds with an SL or a G, unchanged. So if we have an SL or a G, we don't do anything to it. And we'll see what that means as we do this problem. And that's going to be the total ionic equation. Once that's done, we just cross off the spectator ions, and we have a net ionic equation. And it's easier to do this step by step rather than to look at rules. So we have a balanced molecular equation. That's done. We have a balance. Now we have to dissociate, cross that off, dissociate the aqueous ionic compounds. So it means I need to separate these. I need to separate the NaOH. Bring this down. So I have 2 Na, indicating the correct formula, number, and charge. And this is going to be a plus 2OH minus. We're essentially going to do something like that. We have to do that for each one of these aqueous solutions. And I have this cleaned up here, but this is what we're doing. We're dissociating this, we're separating it. 2Na, 1 plus aqueous, plus 2OH, 1 minus aqueous, plus, and do the same thing with this, split the copper and the chloride, split it apart, put the charge of it. Remember, the copper had a +2 charge, because it was copper 2 chloride, Cu2 aqueous, plus 2Cl1 aqueous, and that's yielding 2NaCl aqueous, 2Na, 1 plus 2Cl. And of course, it says that bring down all compounds with the S, L, or G unchanged. So we don't have to do anything with this. We're not dissociating this because it's a solid. It comes down as it is, unchanged. That's what that means. So we keep that the way it is. This right here is the total ionic equation. Total ionic equation. And it's kind of like the picture we looked at on the previous page. We're just writing down all the ions in there and what they're doing. So now, for the net ionic equation, well, we're pretty much done. All we have to do is cross out the spectator ions. Which ions didn't do anything? Well, we look on the left and the right. So this is the line separating the left and the right. And over here we had Na aqueous. Over here we have Na aqueous. They didn't do anything. They didn't combine. They didn't do anything. They spectated. OH. The OH actually did. It combined with the copper, so that's not a spectator ion. The copper combined with the OH to form a solid. The chloride, well, they didn't do anything. These are my spectator ions. So my net ionic equation is what's left. And that would be ballgame. So that was our total ionic equation. The net ionic equation, we simply cross off the spectator ions. And what we're left with is the net ionic equation. And that's how you write it. Very dense, I know, but kind of it's a good review of everything we've done thus far. It kind of summarizes it all. So that is our net ionic equation. What is left after we cross out the spectator ions? And we have another example here, and we've seen this in the previous slide. Just briefly to identify the spectator ions, we have barium chloride, right, aqueous, and it dissociated. The barium separated from the chloride. And we had sodium sulfate. The sodium separated from the sulfate. And when you pour these two containers, or pour these two flasks, these solutions into one beaker, the Na and the Cl, well, they don't do anything. They stay aqueous. The Na is a spectator ion. It's spectating. The Cl, same thing. The Cl is just staying aqueous in solution. It's not doing anything. So the net ionic equation is actually just going to be Ba2 plus aqueous plus SO4 2 minus aqueous yields BaSO4 2. So we've crossed off our spectator ions. This plus this yields this right there. And it's kind of easier. It's easier to visualize with a picture. So we have barium chloride aqueous plus Na2SO4 yields 2 NaCl aqueous plus BaSO4 2. And of course, balanced. This is the balanced version of it. It is balanced. And I did separate it all. This is what the picture shows. We dissociate these objects. Again, mental errors. This gets dissociated. This gets dissociated. This gets dissociated. That's all we did with these. We separated the ions and indicated their charge. And then we crossed off the spectator ions. The chlorine, the chloride, and the sodium, they didn't do anything. So the final reaction was just barium plus sulfate yields barium sulfate solid. And we ended up with that as our net ionic equation. So yes, these are dense. They require you to do bookkeeping, keeping track of charges, and it's really a great review of everything we've done in this chapter because you really got to know how to do everything to be able to do these. Hopefully that helps. This is Mr.